Welcome, Honors Algebra 2, to 5-4, which is what we're going to be learning today. So let's get into it. We are doing it just on a separate piece of paper because that's exciting. Okay, so let's get into 5-4. 5-4 is everyone's favorite section, logarithmic functions. Okay. Oh, that is so blurry. Yikes. Let's see. See, it's like we're back in class. Or I'm just trying to fiddle with the document camera. Okay, so logarithmic functions is what we're going to be starting today. So it's going to be bringing together everything that we have kind of like been introducing and talking about in these last three sections. So we have been talking about exponential equations, right? So we have, I feel like my handwriting today is not great. Okay, so we have been dealing with exponential equations. And that exponential equation looks like this. We have f of x equals a to the x power. Now, exponential equations are super important. They're something we see in the real world often. Exponential equations are how your savings accounts, your loans, bonds, anything with interest is calculated. We use exponential equations to calculate those types of things. And what if I instead said, okay, well, what if I wanted to solve for x? What if I needed to know what x was? Which is actually something that's very common because in most interest-based equations, x is actually representing t and t is representing time. So if you ever think to yourself, okay, I know my interest rate is going to be 2%, and I know that I right now have $500 and I need to make it $8,000. So I want to figure out, well, how much time is that going to take me? Well, that's where the exponent would come into play. So you could do yes or check, or we can think about solving for x. Now, that would be thinking about the inverse. So what's the inverse of an exponential equation? So to find the inverse of an exponential equation, the first thing I would do is always rewrite, instead of f of x, I would write y equals, and then start the process from there. So an inverse of an exponential equation inverse, okay. I feel like I should talk while I'm writing, but I really can't multitask like that when I'm writing in capital letters. Lowercase, I can. Capital letters, I don't know why I can't. Sorry for the poor equation words over there. Okay. So first thing we do when we're finding the inverse is swap the x and the y values. So we'd write x equals a to the y power. Now, at this point in your math careers, we don't know how to get that y by itself. And the only way to get y by itself is by using a logarithmic function. And so the way that we would rewrite that is going to be log base a of x equals y. That is the only way that we can ever isolate an exponent, is with a logarithmic function. So we're gonna say that. I'm just getting my pens ready. Okay, so the only way to isolate an exponent is by using logarithmic functions. Oh, the stupid thing over here makes it difficult to write. Okay, so we're going to be talking a lot about logs and how to rewrite an exponential equation as a logarithmic. So today is just like an introduction to a log. And a log is really just like another way of writing a number. It's another way of writing an exponential equation. So don't get tripped up by the word log. It's fine. It's nothing crazy. The more comfortable you get with it, the easier this whole section is going to be. Okay, so really the biggest thing, like I said, is going to be understanding really fast how to go from a logarithmic to an exponential. So let's talk about that and look at that, because that's exactly what we did here. We went from an exponential to a logarithmic. Okay, so if I'm going to have a logarithmic. I always feel like I'm spelling logarithmic wrong because of the A, but here we are. Okay, so the logarithmic equation, if I have log, I'm going to write this kind of big, and just ignore, I often will do cursive L's sometimes when I'm like trying to write it fast. Just, no, it's an L. So log, let's get lots of colors up in here. Log base A of x equals y. Okay, so first thing I want to say is I want to say it as I would read that, just like I did. So this is read as so how we would say this is log base A of x equals y. So log base A of x equals y. Super important. It's just how we read it. So A is what we call the base. X is what we call the argument. And we don't really have a name for y because y is just the the answer, what the log is equal to. Okay, so like I said, going back and forth from a logarithmic to an exponential is going to be super, super important. So we're going to show you, or I'm going to show you, I don't know who this we is. And I'm going to write exponential. Okay, so to rewrite this logarithmic as an exponential, we would write it with K. A is the base of the log, and A is going to be the base of the exponential. So it's going to be A to the y power equals x. So the base of y is equal to x. Now sometimes, and I'm going to show this to you on a separate piece of paper because I don't want to put it Sometimes what you'll see is, some teachers teach it like there's like a loop-de-loop method. And you'll see me sometimes do this on my work. So if I write the same thing, so log base A of x equals y. And it's going to be hard for me because I'm going to have to show you the loop-de-loop without putting my hand over it. So the loop-de-loop is like you take, I'm going to try without running it, A to the y power equals x. So it goes A to the y power equals x. And now to go back to a log, it's literally like the same loop-de-loop. It would be log base A of x equals y. So there's the loop-de-loop. I don't think about it like that, but you can. Like, that's another way of just memorizing it. I always just think the base of the log is the same as the base of the exponent, and a log is always equal to the exponent. That's kind of like how I always think about it. There's a lot of different ways that you guys can think about it. Okay, so this is huge. This is probably like one of the most important things of this entire section. If you don't know this, let me rephrase this. If you don't know this, then you're not going to be able to follow through with the rest of this unit. So this part here, just knowing how to go from a logarithmic to an exponential and then an exponential to a logarithmic is huge. So we're going to do a bunch of examples. We're going to go through that right now and do a lot of practice. Okay. Sorry, I'm just making space on my table for myself. Okay. So let's get into some examples. Okay, so we are going to start by converting each exponential function to logarithmic form. So convert each logarithmic to exponential form. I could have written that up there. I don't know. Here we are. 2020, what a year. Okay, so if I wrote an exponential equation, so 2 to the third power equals 8, this is asking, okay, how do I write this in logarithmic form? Oh, sorry, I'm a mess. I was like trying to readjust my sitting placement and I kicked the table. Now my knee hurts. Okay, cool. So the way that we would do that, you can do the loop-de-loop. So I'll show you with that. I had a pencil. Oh, there's a pencil. So the loop-de-loop would be log base 2 of 8 equals 3. But like, I just think about it without writing all over it, you know. Okay, or we can think, okay, so the base of 2, the base of the exponent is 2. So when we write our log, that's going to be log base 2. The argument is always the exponent. I'm sorry. That was so dumb. That was not what I meant to say out loud. I feel like I should wipe this out. I feel like I should go back and rewrite this, but I'm not going to because I feel like sometimes my mistakes and seeing them bring you joy because it's like being back in school when I would make mistakes with you in class. I'll just continue to think like that. Okay, so the argument is always like this part, what it's equal to, this 8. The log is always equal to the exponent. Sorry. So log base 2 of 8 is equal to 3. Huh. That was a terrible first example, so I'm sorry. But okay, so let's kind of rephrase that. So when we're rewriting something as a logarithmic, the base is always the base. The log is always equal to the exponent, and then the argument is like what's left. Or loop-de-loop, 2 to the 8 power, or log base 2 to the 8 equals 3. I'm having a hard time with words apparently today. I'm going to get through it. I'm going to power through the day. So that's how we would rewrite it. That is how we would rewrite it in terms of logarithmic, a logarithm. Okay, so I'm going to do this one with you again. I would normally say try this one on your own, but I feel like number 1 was just such a terrible first representation. Let's do 2 together. Okay, so 2, we're going to have x to the pi equals 1. Okay, so again, you can do the loop-de-loop, but the way that I think about it, and maybe I won't use colors here because the colors might throw me off, might throw you off, but okay, so I think it's going to be log base, whatever the base of the exponent is. Log is always equal to the exponent, and so it's log base x of 1 equals pi. And that's it. Okay, so what I want you guys to do, I'm going to write 3, and I want you guys to try this one on your own. So 5 to the x equals m. So take that exponential and then rewrite it as a logarithmic. So try this, pause it, come back, see how you did. Okay. Hopefully you paused it, came back, you're checking your work. So the way that we would write this as a logarithmic would be log base 5 of m equals x. And that's it. Okay, so now instead of converting each logarithmic to exponential, let's go backwards. Let's convert each exponential to a logarithmic. Because really, that's going to be something we're going to be doing a lot. Okay, so I'm going to write that, convert each exponential oh my gosh. You guys, I like can't today. My directions are wrong. Up here. I'm so sorry. Okay. I'm going to pause the video. You're not going to even know that I'm pausing the video. I'm going to pause the video and I'm going to drink some of my coffee and then I'm going to get back into the video and you won't even know I paused it. So you probably do know I paused it because now all of a sudden the directions are fixed. But so this was supposed to be convert each exponential because we started with exponentials to logarithmic because we ended with logarithmic. And this is supposed to be convert each logarithmic function to exponential form, which is what we're going to be doing a lot of. I did drink some coffee, feeling a little bit more awake, feeling better. Hopefully this goes better. Okay, so we're going to convert each logarithmic function to exponential form. Hopefully you fixed your notes, you've copied down that sentence, and my rambling is done. Okay, so we're going to get into another example. So if I gave you log base 4 of 64 equals x, how would we rewrite that as an exponential? So again, you guys can do that like loop-de-loop thing. It works the same way going from exponential to logarithmic as it does going from logarithmic to exponential. So that would be 4 to the x power equals 64. So it's like you're grabbing the first all the way out into the middle. Grabbing the first all the way out into the middle. So if that helps, great. If it doesn't, I don't know. Hopefully this other way works too. So I always think, okay, the base is 4. The base is always the same. And then a log is always equal to the exponent. So a log is always equal to the exponent. So 4 to the x power equals my argument, 64. Now that I wrote the pencil, the pen isn't going. Now I'm just going to like rip a hole through it. And so that would be exactly how we would rewrite this as an exponential. So 4 to the x power equals 64. Now, we could go one step further. What if I said now, what if I was saying, okay, what if we solve for x? Well, what is x here? So we're thinking now we can actually throw it back to 5-3 and think about, can I get 64 to have a common base as 4? Can I rewrite 64 with a base of 4? And you can. So 4 to the x is going to stay the same, and 64 is going to be 4 to the third power. And then, now is the easy part. We set our exponents, x and 3, equal to each other, just like we were doing in 5-3, and I've solved for x. So x is equal to 3. And ultimately, at the end of the day, why is this important and why do I want to solve for a log or for x is because you're ultimately solving for the log. And that's what's going to happen. You're going to be given problems that look like this, log base 4 of 64, and it's going to say evaluate. And we'll do some examples of that later. And you would do basically exactly what I did here. And so you're saying log base 4 of 64 equals 3. So that's kind of just like putting it all together. But let's get back to just converting each logarithmic to exponential. Okay, so if I have log base 10 of 1 equals y. Okay, what I want you guys to do is pause me here, try to rewrite that as an exponential on your own, and then go from there. So pause me here, rewrite it as an exponential, and then come back and check your work. Okay, so I rewrote mine as an exponential. So that is the first part. And now let's actually do what we did over here. So let's solve for y. Now, what exponent makes anything turn to 1? What's an exponent? What exponent do we know? Anything to the what power equals 1? And we know that's 0. Y equals 0. Big part. It's something that we're going to be talking about again in another section. Knowing that. So the exponent that turns a number into 0 or into 1 is 0. So the exponent that makes any number equal 1 is 0. Yeah. Okay. So that means, again, we can throw it back to what we were talking about over here. Log base 10 of 1 is equal to 0. Now, log base 10 is actually a really important log. It's called our common log. And our common log is actually on our calculator. So if you look on your calculator and you look at like our most common buttons for logs, we have log and ln. We're going to get to ln in literally like a minute. Log is called a common log. So anytime you have a base of 10, that's called a common log. And I'm going to get to that in a second. So I won't write a note here. But the way that we actually write it, whenever you have a base of 10, you always, like, you don't actually have to write the base. So you can actually rewrite this as log of 1 equals 0. So whenever there isn't a base, you can assume it's 10. So just like here, like if I did log 1, I would get 0. So it's assuming the base there is 10. When there is no base, you can assume the base is 10. Just like if I have x, I can assume that the exponent on something is 1. Just like if I have x squared, I can assume the coefficient in front of it, even though there is none, is 1. So here, we can assume when there is no base, the base is 10. And we're going to write a note about that in a second. Okay, so last one. Try this one on your own. If I gave you log base 5 of x is equal to 2. So pause me here, rewrite this one as an exponential, and then come back and check your work. Okay, so you should have gotten 5 squared equals x. Remember, you guys can do the loop-de-loop. You can do whatever you want. I just do it like, okay, 5 squared equals x. And so we're thinking base is base, log is always equal to the exponent, argument is what's left. Or you just go, base out middle. However you want to think about it. My laundry is done if you can't hear that. Okay, so now if I were to again say solve for x, well, x is equal to 5 squared. We know 5 squared is equal to 25. X is equal to 25. So you're going to see in your homework tonight, you're going to see problems that are like that, where you're converting, where you are solving for x, where you're evaluating, and we're going to get through all of those examples in this video. So I am going to flip my page. If you haven't, for some reason, copied something down, you can pause it. The beauty of video, but I'm going to flip mine now and start on a fresh page. Okay, so like I was saying before, common logarithm. So let's actually make a note of that because it's super, super important. So we're going to start there with common logarithm. Common logarithm is going to be super important for us because, like I said, it's a button on our calculator and we're going to be able to use our calculators a lot for this. Okay, so a logarithm with a base 10 is called a common logarithm. And can be written without the base. Yeah. Okay. So let's actually highlight some of that. So common logarithm, super, super important. So a logarithm with a base 10 is called a common logarithm and can be written without the base. Huge. So whenever you have something like log base 10 of x, we actually wouldn't write it like this. You would actually want to rewrite it as just log of x. So when a log has no base, you can assume the base is 10. Every single time. So this is so, so huge. It's something that you're going to see a lot. So it's super important. So again, when a log has no base, you can assume the base equals 10. Okay, so when the log has no base, you can assume the base equals 10. Okay, let's talk about another one. So like I said, on your calculator, there are two log buttons. There's log, which is our common log, and then there's ln. ln is our natural logarithm. It's huge too. So I think in 5.3 we talked about E. We talked about the letter E, which represents a number. And a common log or a natural logarithm, ln, is with a base E. So let's write about a natural logarithm. Okay, so a natural logarithm, a logarithm with a base E is called a natural logarithm and can be written as ln. Okay, so again, let's see. We have, if you had log base E of x, you would not write it like that. So you would always, always want to write it as ln of x. So ln of x is how you would rewrite it instead of writing log base E. So these are like the mathematically correct way of writing these two things. Super important. So again, a natural logarithm is with a base E, can be written as ln. Okay, so what we're going to get into now is some examples with evaluating logarithms. So let's get in to some examples. I swear I'll start these off a little bit better. Okay, evaluate the logarithmic expression. Okay, so my first one, I think I'm in 7, is going to be log of 100. So first thing first, what is the base here? Do we see a base? No. So what base can we assume that the base equals? And again, when there is no base, we can assume that the base equals 10. So if you need to, when we're evaluating these, if you need to rewrite this as log base 10 of 100, then rewrite it. But your answer shouldn't be written like this. I would mark you down if your answer was written like this. I would want your answer, whenever it's a base of 10, to be written without the base. Okay, so now we're thinking, and some of you guys can do this in your head, and some of you guys can just think of it without having to rewrite anything. But if you can't, if you're like, I don't know, I always rewrite as an exponential. And I always will think, okay, let it be equal to x. So when I convert it to an exponential, just like we were doing in the prior examples, that would be 10 to the x power equals 100. And so I'm thinking 10 to the what power gets me 100? Well, think about it. Pause me and think about it. X should be equal to 2. So that tells me, well, what does log of 100 equal? Log 100 equals 2. And that's my answer. So you guys, like a lot of you guys, I think will be able to do this mentally, like after you get the hang of it. And some of you guys won't. Some of you guys are more visual people. I really do like to, like sometimes I can do them quick in my head, but a lot of times when I'm like, I need to think about it, I will rewrite it as an exponential and go from there. Now, this one, because we have that button on our calculator, we can actually do that one in our calculator. Log 100 gets me 2. Okay, now let's do another one without a common logarithm. So it's something that we wouldn't be able to use our calculator on. So log base 3 of 81 equals 4. So either way you guys want... I don't know what's happening to me today. But I gave you the answer. So you know what? I'm going to just rewrite another one. So log base 3 of 81 equals 4, because 3 to the 4th power equals 81. Oh, what a day it's going to start for me. Okay. What if I gave you, I have to think of one now. Okay. Log base 5 of 125. What does log base 5 of 125 equal? So if you guys want to pause me here, if you want to think about that one, if you know it without doing anything, great. Pause, think about it for a minute. What does this equal? Now, if you need to convert it to exponential, that's fine too. So the way that I would convert that, I always assume it equals x, and then I go, okay, 5 to the x power, 5 to the x power equals 125. And then I think, what 5 to the what power does equal 125? And you can either do it like we were doing it in 5-3. Think about, well, how can I rewrite 125 as a base, with a base of 5? Or you can just think about it, like we did over here. So you can think about it either way. And then we know x is equal to 3, which we then know log base 5 of 125 equals 3. Okay, let's try a little bit more challenging one. So I promise I won't write what it's equal to. Log base 1/3 of 27. Okay, so I want you guys to pause, and I really do want you guys to think about that one on your own. And I encourage you guys to think about that. Think about rewriting it as an exponential first to kind of help you, and use what you know from 5-3 to really help you to solve this one. So use your prior knowledge to come up with the answer for this. So pause, think about it for a little bit, come back, see if you did get it correct. Okay, now first with this one, some of you guys will be able to do these in your head very quickly, and some of you guys will have to rewrite it. So I'm going to start by just rewriting it. 1/3 to the x power equals 27. Now, remember what I said in 5-3. Whenever you're getting a common base, you want to rewrite the fractions with an exponent, with a negative exponent. So this is going to be 3 to the negative 1x, and 27 is 3 to the third. And then I can power to a power multiply. And now I can set my exponents equal to each other and solve for x. Which tells me log base 1/3 of 27 equals -3. Now, if you guys can do that without this whole process, that's fine too. I'm totally fine with that. That doesn't bother me at all. Okay, so let's get into a few more. And I know I am seeing how long this video is, and I get that. And if you guys at any time want to pause the video, take a break, come back later, I get it. I would too. So do that, pause where you need to, and then come back and we'll do some more examples. Okay, so I'm going to, this is our last set of examples. We're not going to do every single one that I normally would do. Okay, so we're going to solve for x in our next little batch here. And we're going to go on to 10. Okay, so if I gave you, let's see, log base 8 of x equals 2. And I said, okay, solve for x. Think about what would be your first plan of action that you would do to solve for this. And hopefully you're thinking, first, I would convert to exponential. And that is correct. I would convert this to exponential first to help me. And so the way that we would do that, okay, 8 to the second power equals x. Well, what is 8 to the second power? 8 squared, 64. So 64 equals x. And that's it. That's my answer. Solve for x. Okay, so let's move on to another one. Let's see. Okay. If I gave you log base 3 of 4x minus 7 equals 2, and I said solve for x, what would be your first thought there? It would be the first thing that you'd want to do. Hopefully you're saying convert to exponential, and you would be correct. So we'd go 3 to the second power equals 4x minus 7. And now that's a pretty straightforward problem. We know 3 squared is 9. And I can solve from there. I add 7 to both sides. To get x by itself, I divide both sides by 4. And I get x is equal to 4. And that's my answer. I've solved. Okay, so what I want you guys to do, I want you guys to try this one on your own. This is supposed to be 12. So log base 4 of 8x minus 3 equals 3. So I want you guys to pause me here, use what we did in 11 to help you, and try 12 on your own. Okay. So you should be coming back to check your work. I would have first step, always, just like we've been doing on all 10, 11, and what we're going to do on 12, I'm going to rewrite it as an exponential. 4 to the third power equals 8x minus 3. And then I'm thinking, what is 4 to the third? 64. Add 3 to both sides. I get 67. Divide both sides by 8. That can't be divided, so I just leave it as 67 over 8. And that's my answer. Remember, if you guys have any questions on any part of the notes, please come to office hours, get the help that you need. You guys can email me. You guys can text me on that number. Whatever you guys need help with, I am happy to help you guys in any way. Okay, we're just going to do a couple more and then we'll be done. I know this is a long one. I'm sorry. Okay, let's go to 13. So if I gave you ln of e is equal to x. Now remember, ln is our natural logarithm. So the first thing, just like with a common base or with a common logarithm, I rewrite it with the base of 10 to help me. You can rewrite this one as like log base e to help you as well. So log base e of e equals x. Now from here, what would be our next step? What would be always, just like we've been doing in 10, 11, and 12, what would be the next thing we would do? And that would be to rewrite it as an exponential. So e to the x power is equal to e. Well, what does x equal then? Remember, when there's no exponent, we can always assume the exponent is 1. So that tells me x is equal to 1. Which tells me ln of e is equal to 1. Now, we can actually do that one because we have that button on our calculator. We can do it in our calculator. So if I typed in, now ln is here, and ln of e, remember e is above the division sign, equals 1. We get the same thing. Okay. Let's do... We're going to do 3 more examples, maybe, if I can fit them on the singular page. Okay, we're going to do 2 more. Okay, so 14 is going to be ln of e to the 4th equals x. Okay, so I want you guys to pause me here. I want you guys to think about this problem on your own. And I want you guys to think about what x is going to be equal to. Okay, so you should be coming back and thinking, going through your steps. Now, first thing I would always do is rewrite it as a logarithmic. So it would be log base e of e to the 4th equals x. So instead of writing it like that, it just helps me to visualize it. If you don't need to do this extra step, don't do this extra step. Then I'd write it as an exponential. E to the x power equals e to the 4th. And now you should see it's actually a really straightforward answer. X is equal to 4. Again, I can type that into my calculator and I should get 4 as well. E to the 4th power, and I get 4. Okay, Let's try one more and then we're going to be done. Okay, so if I gave you e to the 4x equals 20. Now, this is a little bit different than what you guys have been doing in all the other prior examples, so I'm going to do this one with you. So when the exponent, or like when the variable is part of the exponent, and I cannot get the same base, so I can't rewrite 20 in terms of like a base of e. When I can't get the same base and you're solving for an exponent, you want to convert to logarithmic form. So we're going to do that right now. So instead of having this as an exponential, we're going to actually rewrite it as a logarithmic. So that would be log base e, which we know is ln, log base e of 20 equals 4x. Now, I know I have a button for ln of 20. I can solve for that on my calculator, which is what you guys are going to do. So to solve for x and to keep solving for x, we would divide by 4. Now, something that's super, super important here. So x, you can write it in two ways. Sorry, I'm just going to move it so I can write better. X is equal to ln of 20 over 4. Now, this is my exact answer. And what's really, really important to know and understand is you cannot simplify the 20 and the 4. This does not turn into ln of 5. Because ln of 20 is not 20. ln of 20 is a number, right? If I did that, ln of 20 is not 20. It's 2.9957, da, 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 da. So ln of 20 and 4 we cannot simplify that. So I'm going to write that so you guys remember. Cannot simplify the 20 and the 4. The way that we can simplify that is by using our calculator. And so the way that I would do that, if I were to type that entire thing into my calculator, what I would do is ln of 20, put a parentheses, divided by 4. If you don't put a parentheses, you will not get the correct answer. So you need to make sure you do end the parentheses when you're doing like an ln or a log. So x here is equal to 0.75. Okay, that's it. That's all the examples we'll do for today. I am sorry that this video was so long, but good for you for getting through it. I am sorry I made so many mistakes in this video, but good for you for laughing at me. Hopefully that was like a comedic relief for how many mistakes I made. But I hope you guys are doing great. I really do miss seeing you guys and being in zero period. Let's be honest. I miss being in zero period. So I hope you guys are having a great day. I hope you guys have a great week. Yeah, if you guys need any help, remember you guys can call me, you guys can text me, you can email me, you can go to office hours. So many ways to get that help. Just please, please, please don't struggle. Get the help that you need from me. Okay, have a good day. Bye, guys.